Welcome to educator.com. In this lesson, we're going to be learning about square roots. We'll be learning about square roots and using them for situations such as finding the length of a square object or for creating designs. Vocabulary for this lesson includes perfect square. A perfect square is the area of a square whose length is a whole number. So for example, perfect squares are numbers like 9, 16, 25. For example, because it's a perfect square because you could have a 3 by 3 square, which would equal, the area would equal a perfect 9. A square root is the inverse operation of taking a square, and it's finding its root. So a number that when multiplied by itself equals the original number. So for example, in this case, if we go to our above example, the square root of 9 would be 3. Because when you multiply 3 by itself, you go back to the original number, 9. Every positive number has two square roots. For example, the square root of 25 is 5. But if we're just going to talk about the roots of 25, there are two ways you could equal 25. You could say 5 times 5 equals 25, or you could say negative 5 times negative 5 equals 25. So notice here that the square roots of the number are opposite. The roots of 25 are both 5 and negative 5. The numbers are opposites. When you see the symbol of square root, that's only asking you for the positive. Mathematicians have agreed that the square root symbol only represents the positive root. So let's compare some examples. The square root of 25 is 5. It's only the positive value. However, here there is a negative out front. So when we find the square root of 25, we still want to add the negative that's out front. So when there's just the symbol square root of 25, your answer will be a positive. However, if the problem adds a negative to the front, your answer will be negative 5. You won't ever see a situation where it's negative 25 on the inside until you start working with imaginary numbers. But in this case, in this level, you won't see the negative on the inside. Find the square root. So notice here in 81, we do not have the square root symbol. So they're asking for both roots. 9 times 9 will give you 81, so that is one of the roots. And negative 9 times negative 9 will give you 81, a positive 81. So that's the other root. So the square roots of 81 are 9 and negative 9. The square roots of 121 are 11 and negative 11. When multiplying 11 by itself, you'll have positive 121, and when multiplying negative 11 by itself, you'll get 121. Sometimes you may need to estimate square roots when you don't have a perfect square. So for example, 23, there is no number multiplied by itself that will give you 23. But let's look at what we have in the range. 4 times 4 equals 16, and 5 times 5 equals 25. Well, this one is a lot closer. 25, the answer 25 is a lot closer to 23 than 16 is. So if I were to estimate the square root of 23, I would say it's about 5. This squiggly equal sign here means approximately or about. So the estimation of the square root of 23 is about 5. 390. Well, I know that 20 times 20 equals 400. That's a little bit over. Let's see 19 times 19. 8, 9, 17. Hold the place, 9 and 1. 1, 16, 361. 19 times 19 equals 361. So that's a lot lower. So this estimation is closer. So the approximate square root of 390 is about 20. Let's first focus on the square root of 125, and then we'll remember to put our negative on at the end. So 125, the approximate 11 times 11 is 121. That's a little bit under. But next, 12 times 12 would give us 144, which is a lot farther away from 125. So let's take this as our answer. So the negative square root of 125, well, we know the square root part of 125 is approximately 11, and then now we also want to put our negative on at the front. Let's try some more estimating square roots. You need 58 feet squared of land to plant a square garden. About how long will each side be? Well, because 58 isn't a perfect square, the problem asks us about how long each side is going to be. So we're going to be planting a square garden, and we want to know how long we can make each side of the garden in order to be able to fit it inside the plot of land. So let's try some roots that are going to get us close to 58. 8 times 8 is 64. Well, that seems a little bit large. We want to be able to fit it inside the land. And 7 times 7 will give us 49. So let's see which one is closer. 64 minus 58 gives us 6, a remainder of 6. So 64 is 6 units away from 58. And let's try 58 minus 49. 18 minus 9 is 9. So it seems that this answer is closer. So approximately, the approximate square root of 58 is about 8. So about how long is each side going to be? Each side is going to be about 8 feet long. However, remember that this problem is asking for about, and in fact, in real life, we would only want to use this to estimate how much materials we need to buy, because 64 is larger than 58. Simplifying square roots. Sometimes you may see an exponent along with the square root symbol. Let's see how we could simplify this. The exponent means that I'm going to multiply it twice. So I'm going to take the square root of 36 and multiply it with the square root of 36. The square root of 36 is 6, because 6 times 6 is 36. The square root of 36 is 6, and 6 times 6 equals 36. So notice that that is this part of the equation. So in fact, the symbol square root and squaring the number cancels each other out. So in this case, if you could take a guess, what do you think the answer would be? It would be 121. Let's write it out and see. This exponent tells me to multiply the square root of 121 twice. And the square root of 121 is 11. And 11 times 11 equals 121. If you don't remember that the square root symbol and squaring a number cancels each other out, you can just expand the equation and simplify it. A square table has an area of 18 feet squared. Estimate the length of each side of the table to the nearest foot. Since 18 is not a perfect square, we have to estimate the length. So estimations that are close. 4 times 4 will give me 16, and 5 times 5, another perfect square, will give me 25. 16 is a lot closer. So we would say the estimation of the square root of 18 is approximately 4. And in this case, we're saying to the nearest foot, so about 4 feet. Simplify the expression for x equals 9. So let's use our substitution in this equation, in this expression. Negative 2 times the square root of 9 minus 5. The square root of 9 is 3. Negative 2 times 3 is negative 6, and we haven't used the negative 5 yet. And lastly, negative 6 minus 5 is negative 11. So in this case, we substituted the 9 in place of the x and evaluated that first and got 3. And then we used order of operations and continued. Negative 2 times 3 is negative 6. So you could think about this in terms of order of operations as being the parentheses. A square room has an area of 148 feet. About how long is each side of the room? So once again, 148 is not a perfect square, so we have to estimate about how long is each side of the room. Let's try some numbers. I know that 12 times 12 is 144. That seems the closest because 13 times 13 is going to get me up to 169. So let's go with this. So in looking at the square root of 148, it's about 12. So each side of the room is about 12 feet long. Let's simplify the expression for x equals 16. We're going to use substitution here. Negative 16 squared plus the square root of 16. First, notice that this exponent is not attached to the negative. So the exponent is only telling us to work with the 16. So I'm going to do 16 times 16 here. 36, 6, 7, 8, 9, hold the place, 6 and 1. 6, 15, 256. So with the negative out front, negative 256 plus the square root of 16. The square root of 16 is 4, so negative 256 plus 4. We're adding integers here. And a negative plus a positive, the signs are opposite, so we're going to subtract. 256 minus 4 is 252. And the negative was the larger, so we're going to say our answer is negative 252. So quick recap, we put the 16 in place of the x here. And the exponent was not attached to the negative, only to the x. So we multiplied 16 times itself, and we got 256. So our answer was negative 256 once we put the negative out front. Then the square root of 16 is 4. And we notice the signs of our integers are opposite, so we have to subtract. And then we always take the sign of the larger number because on the number line we are more in the negative direction here. So our answer was negative. Thank you for watching educator.com.